Hello friends. So today we will start talking about graphs of various functions. What is a graph? Graph is a representation of any relation or function on a Cartesian plane. Now, what is a Cartesian plane? I have spoken about it, but let's get a little deeper into it today. A function is, say, y equals to fx. This function could be a function which is linear in nature, but a linear function is a function like this. So y is equal to f of x, and f of x is 2x minus 1. Suppose the degree is different. The degree is 2. If you notice, x square plus y square equals to 16. Or I can write down y in terms of x as a y square is equal to 16 minus x square, right? So from here, we can find out that, okay, y is equal to some function of x, that it is equal to gx. Now, all these relations can be represented by a curve in a coordinate system. Y equals to fx has such a representation. Now, what is a coordinate system? It is the Cartesian plane. So you have x-axis and y-axis. X-axis values will lie out here. The horizontal line is called the x-axis, and you can have values 1, 2, 3, 4. We have already spoken about number lines. So this is what it looks like, are on a line. So here you have 0 in the center, minus 1, minus 2. And this has to be equidistance. Similarly, you have a y-axis. Since the representation will be x comma y, we will be representing on a graph all the ordered pairs x comma y. So you will have in the coordinate system, you will have y also. So y values will lie here. Y values, negative y values will lie here. So this is what you need to, first of all, understand. What kind of numbers will lie on these 4 portions that you can see? Once you have written down these numbers on these lines, we get a fair idea of what numbers lie where. These 2 lines are dividing this whole portion into 4 portions. So these are called quadrants. This is your quadrant 1. And quadrant 1 would contain points like 1, 1, 1, 2. Now these are points where x-axis value and y-axis value both are positive. As you can see, the numbers on the line, they're all positive. So in the first quadrant, you will have all plus numbers, that is positive numbers. On the second quadrant, now where is the second quadrant? To the left of the first quadrant lies the second quadrant. And clearly you can see that what kind of numbers you will find in this quadrant. The y values are positive, but the x values are negative. So the numbers that I will find here, the points that I will find here, would contain on the x-axis, it will contain negative numbers, but on the y-axis, it will contain positive numbers, right? Quadrant 3 consists of numbers. If you notice, you have negative y's and negative x falling out here. So numbers like quadrant, we will get negative x and negative y. So minus. Quadrant 4. Now quadrant 4, if you notice, if you observe, what kind of points are lying here? If I may take up a point here, this point clearly is where x is 2, which essentially means that this distance, this horizontal line is of length 2, and the vertical line is of length 1, but it's to the direction down here where you have negative y's. So hence you have minus 1 here. So we will say that the point is 2 comma minus 1. This distance or this vertical line is 1 unit, but it's to the down direction out here, which of the y-axis, so it's negative. So 2 minus 1 is what you get. So clearly that means, what are we getting here? In this quadrant, you will figure out that you will get all positive x's because it is to the positive side of x-axis, but the negative y's because it is to the negative side of the y-axis. So this is your coordinate system. And once you start plugging in the ordered pairs which are satisfying a particular function relation, that will create a curve. After joining all the points, you will get a curve. Now, we will talk about such graphical representations. This is the basic of graph that you should know. Once you know this, you can talk about the graphical representation of any function. So if I give you a coordinate plane like this, and I give you a point P, which is P comma Q, what does this point signify? This point is signifying that the x-axis value is P and the y-axis value is Q, which essentially means that the horizontal length, which is your x-axis length, is P, and the vertical length, which is associated to y, that is Q. That's what a point in the coordinate system on a Cartesian plane signifies. This entire plane, you can of course have your markings here. This entire plane is called R2. All R2 points can be represented out here. There are infinitely many. Let's take some examples to understand graphing properly. So suppose we have the function x equals to 5. It's a constant value that x is taking. If I have to represent the value of x equals to 5 on a graph, what would it mean? It would mean that no matter what y is, x going to be just 5. So on a coordinate system or a Cartesian plane, if I want to say that x will be 5, that means x will always be here, and no matter what is y, x will always be here. So which means that this line, vertical line that you see, it represents 5 comma y in terms of ordered pairs. So all the pairs 5 comma some value of y are represented by this vertical line, and that's what the graph of x equal to 5 will look like. It'll be a vertical line. Similarly, y equals to 5 could also be represented on this Cartesian plane. This would mean that no matter what value x takes, y is always equal to 5. So it's going to be a horizontal line, because on this horizontal line, the value of y is fixed at 5. This means we are talking about a line which is representing what kind of ordered pairs? Where x could take any value, but y equals to 5 is fixed. This horizontal line is depicting that fact. Third example, I would like to take both x and y into consideration. So when we're talking about, say, question number 3, x greater than or equal to 0, y greater than or equal to 0, that I would like you to tell me what exactly on the Cartesian plane are we talking about, where x is positive and y, both x and y are positive. That was the quadrant 1, which we represented just a few minutes before. Quadrant 1, that is. Let's now try to depict some region on this Cartesian plane. For example, x lies between 1 and 2 and y lies between 3 and 4 always. If that is the scenario, what would it look like on this coordinate system? If that's the case, then what region are we talking about? We are talking about the region where x is always lying between 1 and 2 and y is always lying between 3 and 4. So let's have two vertical lines telling us that x is always equal to 1 and telling us that x is always equal to 2. And let's have two horizontal lines telling us that y is always equal to 3 and y is always equal to 4. So this would mean that the region that we're talking about lies out here. This region. Let me now move back to the first example that I started with. Suppose y is equal to f of x and y in this case is equal to 2x plus 1. How to graph an equation in two variables on a Cartesian plane? So the best way to go about it is that you find out certain points that are satisfying this relation. So what do we do in that case? We give value to x and we derive value of y. In other words, we are actually trying to figure out in some way what is the probability range of this function using the domain values. So, well, the domain of this function clearly is entire R because we do not see any restriction here. I can put positive, negative real numbers, all kind of real numbers could be taken up here as an x. If that is the case, then that means x can take the value 0, x can take the value -1, x can take the value 1, -2, 2, so on and so forth. But in order to graph, I think 3 points would be good enough for us to be able to get the picture of what this graph will look like. When I put the value x equals to 0, I derive that y is equal to, in fact, 1. On the graph, this point will look like this is 1, this is 0, this is 1 for x. So 0 for x and y, 1. So that means we're talking about this point. If x is equal to -1 and you put the value here, you'll get -2 plus 1, which gives you -1 again. So when x is in fact equal to -1, y also turns out to be -1. Where do you think this point would lie? Now, I know that this is, if we take this distance for as 1 unit, then this is -1 for x, and this is -1 for y. So which means that we're talking about this point here. If x is 1, then y turns out to be 2 into 1, that is 2, plus 1, that is 2 plus 1, 3. Cartesian plane, it would look like x is equal to 1 here, and y is equal to 2 and 3 units out here. So that means we're talking about this point. Now, in order to graph, you join all these points. So let me just join it like this. And then let me take it up in the same direction and take it down in the same direction again. So if you see, this is a relation which is linear in nature and you get a straight line out of it. This graph is a straight line, which also tells you that it's a linear function and the graph is a straight line. In the second example, I took the function x squared plus y squared equals to 25. We can actually write down this function also in terms of y equals to gx. And how will we do that? Y square is equal to 25 minus x squared. Taking the square root, we would know that whether I take positive of the square root of 25 minus x squared or I take the negative of square root of 25 minus x squared, when I will square, I will get the positive value of y squared only. Now, so keeping that in mind, again, what we will do, we will go about the simple process of giving x certain values which are in the domain and getting y values out of it. So suppose I give the value -5 to x, what will I get? The moment I will put x as -5, it's going to be inside the square root, 25 minus 25, that gives you 0. The moment I will give the value -4, what's going to happen? Inside the square root, I will get 25 minus 16. -4 squared is 16. So 25 minus 16 will give you 9. So you will get square root of 9. Square root of 9 plus minus of it. Why plus minus of it? Because please try to understand that y square is equal to, in this particular example that I've taken, 25 minus 4 square. That means it is equal to 9. Now, if you take +3 or you take -3, you square the both, you will get 9 only. That is why, that means y can take both the values plus as well as -3. When you take the value -3 for x, what will you get? You will get 25 minus 9, which gives you 16 inside the square root. That means plus or minus 4 comes out. 4 comes out, but plus minus, it can take both the values. When you give 0 to x, you get plus minus of 5 because put in the value, you will get x square plus y square equal to 25. Similarly, if you give positive value 3 to x, you will get plus minus 4, because it's going to be 60, it's going to be 25 minus 9, that gives you 16 inside the square root. If you give the value 4, you will get plus minus. If you give the value of x, if you take the value of x as 5, you will get 0, because that's what you get inside the square root, right? Now, how to display this on this Cartesian plane or the coordinate system? So we will mark these points. When x is minus 5, let's start with the first value that we have here. When x is minus 5, out here, y is 0. So that means the first point lies here. In fact, when x is 5, then also y is 0. So considering the last point as well, so 5, 0 would get represented here. When x is minus 4, so x is minus 4 out here, y is plus or minus 3. So with minus 4, y can be here also 3, and it can be here also as minus 3. When x is minus 3, y could be plus minus 4. That means it could be plus 4 here also, and it could be minus 4 here as well. When x is 0, y is plus minus 5. That means when x is 0, y could be here also at 5 and here also at minus 5. Similarly, when we go this side, when x is equal to 3, when x is equal to 3, you are getting plus and minus 4. So minus 4 out here, and with 3, you have 4 out here. When x is 4, you're getting minus 3 plus 3. So minus 3 out here and plus 3 out here. Now, if you may try to join it, what will this shape look like? And when you join all these points, what shape do you get? You get a circular shape. It's not linear anymore. It's not a straight line. It's a circular shape. X square plus y square represents a circle with centers 0, 0 and radius 5, as you can see here in this graph. When you have this coordinate system in hand, it is easy to understand the shape of whichever function you are using, whichever function you have with you. It's easy to also figure out what is domain as well as range of this function. Clearly, what you can see here is that x square plus y square will always give you a positive value, 25. It's fixed. So what is the domain of this function? The domain of this function are all x and y's which are lying in between minus 5 and 5. And they're also satisfying a particular relation that x square plus y square should be equal to 25. That's the relation that must get satisfied, and that's how you get this circular shape. But domain and range of two variable functions, something I'm leaving for later on. Now today, I will also, with this explanation, talk about how to make use of a graph, why use a graph, and how it makes our life simpler with a question.